All right, hey everybody, Dr. Marty back. We are talking about functions, and in our last set of notes, we learned about what a function is. We learned it's a relation, which is like a set of ordered pairs, where every input has one output. Okay, so today we're going to talk a little bit about functions in a different way. We're going to learn about them as function machines and also about function notation. Okay, so a function can be thought of as a machine that assigns one output to every input. Okay, it's a machine that assigns one output to every input. So for every number that goes in, every input, every number that it goes in, we're going to get one number out. Okay, so this is what's called function notation. All right, and this is essentially like a machine. So we have this statement: f of x means function of x equals 3x plus 4. Okay, 3x plus 4. So the f here is the name of the function. Name of the function. That's the f. It could be any letter, actually. And we'll actually see some that have f, some that are g's, so on and so forth. Okay? This right here, so it says f and then in parentheses has x, and this is read f of x. Okay? This tells us what number to plug in. Tells us what number to plug in. Okay? Well, what do we mean? We're going to plug a number into here. Okay? This is the actual function. We're going to plug a number in, and which number we choose is based upon what number you see here in parentheses. Okay? I'm going to show you how that works in a second. So we have the name of the function, f of x. X is what tells us what to plug in, what number to plug in. This whole thing is the same as substitute and evaluate. So this is the same as substitute and evaluate. Well, what do I mean by that? Substitute and evaluate. Well, substitute means we're going to plug the number that we see here into this function for x. And then evaluate means evaluate it. So what do we get as an output if we plug that number in for x? So this bit, 3x plus 4 in this case, is just the function. This is the actual function. Okay? So f of x equals 3x plus 4. The name of the function is f. X is the number we're going to plug in. 3x plus 4 is the actual function. We're going to plug whatever input we get here into this value, and then we're going to substitute and evaluate. Well, let's try that. Let's try that. Okay? So here, you can see this. Make sure that we're zoomed in properly. It says find and illustrate f of 2 and f of negative 1. Okay? Well, f of 2 means we're going to plug 2 in for x and see what we get. So I'm going to put a 2 here, f of 2, right? And then we know we have 3x plus 4. So I'm going to plug this 2 in for x. So I'm going to get 3 times 2 plus 4. Well, 3 times 2 is 6. 6 plus 4 is 10. Right? That's what comes out. So we know that f of 2 equals 10. So 2 was our input. That's what we plugged in for x. 10 was our output. 2 comma 10 would be our ordered pair. Okay? How about negative 1? What if we plug negative 1 in for x? Well, 3x plus 4 is our function. 3 times negative 1 plus 4. 3 times negative 1 is negative 3. Negative 3 plus 4 is positive 1. So f of negative 1 equals positive 1. See how that works? All right, let's move on to the second page of notes for today. And this is just going to be some practice. Okay? These are going to be some practice of using function notation. All right? So we're going to start over here on this side. It's function notation. It says let f of x equals x squared plus 3 and g of x equals x plus 1. So if I see f of a number, I'm going to plug that number into x squared plus 3. If I see g of a number, I'm going to plug that number into x plus 1. So f of 3 is going to be 3 squared plus 3. That equals, 3 squared is 9, 9 plus 3, which equals 12. G of 3, well, g of x is x plus 1, so that's going to be 3 plus 1, which equals 4. See how we do this? F of negative 2. We've got negative 2 squared. Remember, f of x is x squared plus 3. Negative 2 squared is 4. 4 plus 3 equals 7. G of 0. We're going to plug 0 in for x here. We're going to get 0 plus 1, which just equals 1. Now, this is going to get a little bit trickier. We're going to compound them. Okay, it says f of 2 plus g of 1. Let's see if we can zoom in. F of 2 plus g of 1. Well, f of 2 is going to be 2 squared plus 3, right? That's f of 2. Plus, so that's f of 2, right? G of 1, which is 1 plus 1, right? We plugged 1 in for x, for g, plus 1. So that gives us 2 squared, which is 4. 4 plus 3 is 7, plus 2, which equals 9. See how we did that? Let's do the same thing here. G of negative 1 plus f of 1. Well, g of negative 1 is going to be negative 1 plus 1, right? Plus f of 1, which is going to be 1 squared plus 3. We get negative 1 plus 1 is 0, plus 1 plus 3 is 4. That equals 4. And we can keep going, okay? So we got this one, which is a little bit trickier. This is f of g of 2. So what this means is we're going to solve for g of 2, and we're going to plug that in to f of x, okay? So we know that g of 2 equals 2 plus 1, right? So let's plug that in to f. So f of 2 plus 1 equals 2 plus 1 squared plus 3. That equals 3 squared plus 3, which equals 9 plus 3, which equals 12. See how I did that? I found what g of 2 was, which is 2 plus 1. I could have solved that for 3 there, and I plugged that into the f. So that gives me 3 squared plus 3. Here we have g of f of 0. Well, that's going to be f of 0, which is 0 squared plus 3 plus 1, because g of x is just x plus 1. F of x is x squared plus 3. So 0 squared plus 3 is going to give us 3 plus 1, which equals 4. So that's making sense, okay? Number 9 is a little bit interesting. 9 says f of y. So now we're going to plug this y value in for x. Well, f, that's just going to be y squared plus 3. Because we plugged y in for x, y squared plus 3. Here we've got g of w. We're going to plug w in for x. We're going to get w plus 1. All right. Now let's look up here. Here we have f of x equals x squared minus 3x. It says, what's the value of f of 5? Well, f of 5 equals 5 squared minus 3 times 5, which is 25 minus 15, which equals 10. Our answer is 10. Here it says f of x equals negative 3x plus 1. What is f of 3? Well, f of 3 equals negative 3 times 3 plus 1, which equals negative 9 plus 1, which equals negative 8. Negative 8 is our answer. Finally, it says if f of x equals 2x minus 5, which expression represents x plus 1? Well, f of x plus 1 equals 2 times, we're going to plug x plus 1 in for x, minus 5. That equals, we're going to distribute, 2 times x is 2x, plus 2 times 1 plus 2 minus 5, which equals 2x minus 3. That is our answer. Okay? So, function machines, function notation, it's simply a matter of plugging whatever number they give you here, f of whatever this is here, in for x in your equation, substituting and evaluating.